Welcome to another lecture on engineering graphics. Today in this lecture we will solve problems on diagonal scale. So let us start the lecture. Let us read the statement first. Construct a diagonal scale to show meters, decimeters and centimeters when 1 meter is represented by 5 centimeters. Consider maximum length of scale as 4 meters, mark of 2.58 meters and 3.09 meters. As we know that if we have to solve any problem related to scales, the very first step is we have to calculate RF of the problem, means we have to find representative fraction. So let us perform that step first for this particular problem as well. So let us write the formula for representative fraction. Now what is representative fraction? It is length of line in the drawing divided by actual length of line on the object. Now let us search these values in the problem. So let us read the statement again. He says construct a diagonal scale to show meters, decimeters and centimeters when 1 meter is represented by 5 centimeter. Now look over here. He is saying when 1 meter is represented by 5 centimeters. So where we represent? We represent on paper. So on paper or on the drawing, the length is represented by a line of 5 centimeters. But the actual length is 1 meter. So length of line in the drawing will be 5 centimeters and actual length of the line on object is 1 meters. So look over here. We have entered length of line in the drawing as 5 centimeters and actual length of that line on the object is 1 meter. Now after this what we will do? We will convert meters into centimeters. So you see we have converted 1 meter into centimeters. So we got 100 centimeters. Now when you will solve this fraction further, you will get answer 1 by 20. So for this problem we got RF as 1 by 20. So the meaning of 1 by 20 means that we have reduced the size of the drawing by 20 times. Now next step is related to the calculation of LOS, that is length of scale. Now let us read the second line of this statement. Consider maximum length of scale as 4 meters. That means we have to design a scale or we have to draw a scale which should measure up to 4 meters. Now we know that we cannot draw a line of 4 meters on our paper. So for that what we have to do? We have to reduce 4 meters by some proportion. So how much proportion? The answer to that question we got from the first calculation, that is RF. That means we have to reduce 4 meters by 20 times. Then whatever length we will get after that reduction, we will draw that length on our paper and that length will be called as length of scale. So in the second calculation, we just reduce the maximum length of scale by the RF which we have calculated in the first step. So let us see the formula of length of scale now. It is equal to RF into maximum length of scale. So you see we have reduced the maximum length of scale by 20 times so that we should be able to accommodate the length which will represent 4 meters on the paper. So let us see what answer we get from here. We have converted now meters to centimeters. So we have multiplied 100. Then we will get 20 centimeters as length of scale. Now what is the meaning of this? The meaning is that if we will sketch a line of 20 centimeter on the paper, that will actually represent 4 meters. Now let us see the construction of diagonal scale. Now before constructing diagonal scale, we first have to see the definition of diagonal scale. In the previous lecture, we learned about the definition of diagonal scale and we learned that Diagonal scale is obtained after dividing the smallest division on the plane scale further into some equal number of parts by using diagonal principle. So from this definition, it is clear that in order to construct diagonal scale, first of all, we have to draw plane scale. So let us again see the definition of plane scale now. So what is the definition of plane scale? Plane scale is a line divided into some equal number of parts. This is the first statement in that definition. So over here, what will be the length of that line? The length of that line will be 20 centimeters. So he is saying plane scale is a line. So what will be the length of that line? 20 centimeters. It means first step is that we should sketch a line of 20 centimeters, and this line will be continuous thick. Now next he says in the definition, which is divided into some equal number of parts. Now we have to divide this line into some equal number of parts. Now question arises that how many parts I should show for this particular line. In the previous lecture, when we solved problem on plane scale, I discussed that when we have to decide number of parts for the line, we should focus on what is the maximum length we have to show. Now in this question, we have to show a length of 4 meters. Now in that lecture, I said that if the maximum length of scale is up to 10 or less than 10, then make same number of parts. Now you see over here, we have to show the maximum length as 4 meters. It means we will make 4 parts. Each part will represent 1 meters. Now this line is drawn as 20 centimeters on the paper, which is actually representing 4 meters. Now we have decided that we will divide this line into 4 parts. It means length of each part on the paper will be 20 divided by 4 equal to 5 centimeter. Length of each part on the paper will be 5 centimeters, but that part will represent 1 meter. So let us mark 4 parts with the help of scale. So each part is of 5 centimeter in length and it is representing 1 meter. So total length is 20 centimeter and it is representing 4 meters. Now after that we will label these markings with the help of Gothic numerals. So we know that if we have to construct a plane scale, we have to start from the second point. Label that point as 0, 1, 2, 3. Fourth meter will be on the left side of the 0. Now let us label the units. Now this is which scale? This is a meter scale because these 3 divisions are representing 3 meters. So what we will do next, we will draw 2 guidelines and take the gap between these 2 guidelines around 5 millimeters or 7 millimeters and use Gothic letters to write meters in capitals. Now come back to the definition part. So what was the definition of plane scale? Plane scale is a line divided into some equal number of parts and the first part of which is further subdivided. It means now our next step is we have to decide number of parts for the first part. Now question arises that how many parts I should show over here. Now answer to that question will depend upon what is the next unit I have to show. Now he is saying us to show meters. Meters we have already shown. Now decimeters. It means over here we have to show decimeters. Okay, this we have found that over here we have to show decimeters. Now think about this part. This part is representing 1 meter. Fine. And now I want to show decimeters over here. Then I have to see the relation between meters and decimeters. And we know 1 meter is equal to 10 decimeters. Now I know that this is a part of 1 meter. And if I have to convert this into decimeters, then I have to divide this into 10 equal parts. Only then one part will be of 1 decimeter, and we can say that this is a decimeter scale. Okay, now let us see what is the length of this part. Length on the drawing is 5 centimeters and it is representing 1 meter. Now we know that we have to convert this into decimeters. So 1 meter is equal to 10 decimeters. So we will divide this part into 10 equal parts and each part will be representing decimeter. And the length of this part is 5 centimeter. So 5 centimeters divided by 10, then length of each part will be 0.5 centimeters and it is representing 1 decimeter. Okay, so with the help of scale, we will make 10 divisions over here and each division has a length of 0.5 centimeters or 5 millimeters and it is representing 1 decimeter. So let us show 10 divisions now. So like plane scale, what we will do, we will make fifth division slightly longer than the other divisions in order to highlight the midway marking. Now how many decimeters are there? 10 decimeters. And it is which scale? It is a decimeter scale. So over here we will write 10. And below it we will draw two guidelines and we will write decimeters. And we will mark midway marking also, that is fifth decimeter. Now we are done with the construction of plane scale. In the previous lecture, we have learned that while drawing plane scale, after this step, we draw two vertical lines at these 2 points to draw the body of the scale. But this particular question is not related to plane scale, it is related to diagonal scale. It means after this step, we have to convert this plane scale into diagonal scale. Now let us see how we can convert this plane scale into diagonal scale. So for that, we have to again see the definition of diagonal scale. What is the definition of diagonal scale? The smallest division on the plane scale is further subdivided into some equal number of parts by using diagonal principle. It means now what we will do, we will divide the smallest division on the plane scale further into some equal number of parts by using diagonal principle. Now here comes another question. That question is that how many parts I should make for this smallest division for this question in order to convert this into diagonal scale. The answer to that question will depend upon what is the next unit I have to show. So the next unit which I have to show is centimeters. Now come back to this smallest part again. This part is representing 1 decimeter, but I have to divide this in such a manner that I should get a part of centimeter because I have to convert this part into now centimeter scale. So for that I have to see the relation between these two units. I know 1 decimeter is equal to 10 centimeters. Now this is a part of 1 decimeter. So if I have to convert this part into centimeter scale, I have to show 10 divisions over here. So I have decided that for this smallest division, number of parts will be 10. Now those parts we will not draw here because it is a very small length and those parts will not be visible over here. So we'll convert this particular length into centimeters by using diagonal principle. So let us see how to apply diagonal principle now. So as we have decided that I have to divide the smallest division on the plane scale into 10 equal parts to convert this into diagonal scale or to get the third unit, which is centimeters. Now for this we have to apply diagonal principle. So how we will apply diagonal principle? From this end we will draw a vertical line. Now I know on this line I have to show the third unit, which is a centimeter scale. Now one very important point to understand over here. We know that on this line we have to make 10 equal divisions. But the length of each division on this scale is our choice. That means I have the choice to consider the length of each division on this line. If I take length of one part as 0.5 centimeters, and if I have to construct 10 such parts, then I have to construct the length of this line as 5 centimeters, because I have taken length of one part as zero point 0.5 centimeters and I have to make 10 such parts. So 0 0.5 into 10. So total length which I require to show those 10 parts will be 5 centimeters. Now, if you want to take another size, let us say I want to consider 0.2 centimeters as the length of one part, and I have to make 10 such parts. It means 0.2 centimeters into 10. Then for me, this length will become 2 centimeters. So keep this thing in your mind, that when you are constructing diagonal scale and when you are drawing the third scale, then the length of third scale will depend upon the length taken by us for each part, and that is your choice. So for this particular question, I am considering length of one part as 0.5 centimeter. So I have to make 10 such parts. So for me, length of this vertical line will be 5 centimeters. Okay, so I will draw this vertical line of 5 centimeters, and with the help of scale again, I will make 10 divisions, and length of each division is how much? 0.5 centimeters. So in this way we will make 10 equal parts. So I have made the midway marking slightly longer than the other markings. Now one very important point to understand over here, that this particular scale is readable from bottom to top. Let us see all three scales again. This scale is readable towards right of 0. This scale is readable towards left of 0. And this scale will be readable from bottom to top. It means this is 0 for us, and this is the first point. Second, third, fourth, fifth, up to 10. And make sure we should write these numerals in Gothic style. Okay, now this is which scale? This is a centimeter scale. So what we will do, we will draw two guidelines, and in between those two guidelines, in Gothic style, we will write centimeters in capital letters. Now after this, we will complete the body of the scale. Means from this particular point, we will draw a vertical line which will be equal to this length, that is 5 centimeters. Then we will connect these two points with the help of another continuous thick line. Then from these divisions, we will draw vertical continuous thick lines to show all the parts of the scale. So in the next step, what we will do, from all these points, let us draw horizontal lines up to this particular line. And we will keep these lines thin. And we will draw these lines with the help of ruler scale, so that these lines should be parallel to each other. Now after that, what we will do, we will divide this particular length into 10 equal parts. Means we will copy these divisions over here again in order to draw diagonal lines. So as we know, this is a length of 5 centimeter. So we want to copy these 10 divisions over here. It means again the length of each division will be 0.5. So with the help of scale, I will mark 10 divisions over here, and each division will be of 0.5 centimeters, which we have considered over here. Okay, after this, what we will do, from the second last division on the second scale, we will draw a line which will connect to the last division of the third scale, and that line will be thin. If we will do this, you will find that this is a diagonal line. It is not a vertical line. It is diagonal line, or you can say inclined line. Then we will connect next 2 points to draw the second diagonal line which will be parallel to the previous one. Now similarly from the next 2 points, and we will do this up to 0 marking. So see, from 0 also we will draw the diagonal line. Now we have drawn all the diagonal lines, and remember the horizontal lines in this part and the diagonal lines in this part must be continuous thin, and the remaining construction of the scale should be continuous thick. Now we are ready with the construction. After this, what we will do, below the scale we will mention RF and LOS of the scale by drawing guidelines, and we will write these two in Gothic style. Now our diagonal scale is ready. Now we have to answer the question. So what we have to answer? We have to mark a distance of 2.58 meters. So let us see the meaning of this. 2.58. So 2 meters, 5 decimeters, 8 centimeters. Fine. Okay, let us plot this dimension now. Let us see how to plot. Where is meter scale? Meter scale is on the right side of 0. So 1 meter, 2 meter. So we have picked 2 meters from the first scale. Now we'll pick 5 decimeters from second scale. So 5 decimeter or 5th decimeter is over here. Now what we will do, we will pick the diagonal line starting from that 5th decimeter. So this is the line. We have to pick this line from the 5th decimeter. Then we have to pick 8th centimeter. So where is 8th centimeter? It is on the third scale over here. Then we have to pick the horizontal line from 8th centimeter. Now where these two lines are intersecting, that point we have to pick. So what we will do next? Now from 2 meters we will draw a continuous thin line after leaving 1 millimeter gap, and from the top of this point we will draw a continuous thin line after leaving a gap of 1 millimeter, and from object line we will leave a gap of 10 millimeters and we will draw dimension line, and we will draw closed filled arrowheads on both sides and we will label 2.58 meters. Now let us understand why we have done this procedure. Very easy to understand. You see, if I pick this dimension, means 0 to 2 meters, and 0 to 5, so it will become 2.50 meters. But now what I have to do? I have to show 2.58 meters. But if I see my plane scale, on plane scale the next division is at 2.60. So up to this is 2.60, up to this it is 2.50. So I need 8th part of this smallest division to represent 2.58. So in order to achieve, or in order to reach to that part, what we have done, we followed the diagonal line, started from 5, and this diagonal line is inclined towards 6th decimeter, and slowly we are moving towards 6th decimeter. And if I drop a vertical line from here, it will actually point the 8th part of this distance. So following the diagonal line, we are slowly moving towards 8th part. So this is known as diagonal principle. I hope the working of this scale is clear to you. Now let us plot the next dimension. It is 3.09 meters. It means 3 meters, 0 decimeters, 9 centimeters. So from 0 to 3 meters, 0 decimeters. This is a decimeter scale. So 0 decimeter is here only. It means we will pick this diagonal line which starts from 0. After that, we have to pick ninth centimeter. So ninth centimeter is this horizontal line. So we have to pick this horizontal line starting from ninth centimeter. So where these two are intersecting, that is our point. So from this point, we will draw continuous thin line after leaving 1 mm gap, that is an extension line. Then from third meter, we will draw another extension line after leaving 1 mm gap. Then from this dimension line, we will leave 10 mm gap and we will draw a second dimension line. We will draw closed filled arrowheads in 3:1, and on the top of that line, we will write 3.09 meters. So I hope the construction of this scale is clear to you, and how we have solved this problem, that is also clear. Now in the next lecture we will see the construction of this scale, the same question on the grid sheet, so that there should not be any confusion in the construction of this scale.